In this video, we're going to try to write a formula for the polynomial function when we're given its graph. So what can help? Well, we know that every zero in the polynomial, it gives us a factor of that polynomial. This is a very important notion. And I should correct myself, every real zero, because there is a possibility of complex zeros. So for example, here, we know that the function, from this equation, we know that the function crosses the x-axis here at x equals 0, here at x equals 1, and here at x equals -3. Okay, so your graph will display these factors, right? So, and you can, so each zero gives you a factor to a certain raised to a certain power. Okay, and then also there could be a multiplier, a coefficient that's multiplied into all of these factors, and which stretches or shrinks the graph. It doesn't change the x-intercepts. Okay, so we're gonna, each x-intercept gives you a factor in the polynomial function. So with that in mind, let's take a look at this graph now. We have, let's list all of the zeros and try to get their multiplicity of each one. Okay, so the zeros that we have here are -3, and we also have 2, and we have +5. So these are our zeros. Now, what are the multiplicities of them? Well, since here the function goes straight, we at -3, the multiplicity is 1. At 2, we have what's perceived as quadratic, right? So this multiplicity is 2, and at 5, again, it goes straight. So the multiplicity of that factor is 1. So now, which factors do those zeros give us? So the factors are, we're going to have x plus 3 to power 1. We're going to have x minus 2 to power 2. And we're going to also have x minus 5 to power 1. So our function should have each one of these factors, right? So we're going to write f of x is, well, all of these factors, we have x plus 3, x minus 2 squared, and we also have x minus 5. Okay, so notice that we're subtracting each zero from x to create a factor. Only this way, when x equals 5, then this entire factor equals 0. That's the reason. Now, as we mentioned before, there could be a multiplier. We call it a, which stretches or shrinks your graph. Now, so we have this formula, but we need to figure out a still. How do you do that? Well, in order to figure out a, you need to read one point from your graph and plug the values in and solve for a. Now, the point should not be your zeros, because if you pick one of those, then the whole thing is going to zero out, including the a. So we need a different point, okay? But we want it to be readable. And one of those points is a y-intercept 0, -2. It doesn't have to be a y-intercept. It could be any other point. Like, for example, I could choose like 6, 4 as well, I think. But to me, it's not very on the dot, you know. It's like kind of hard to read. Okay, so I choose 0, 2, and that's the easiest point to plug into because all the x's will become zeros, right? So this is the output value, -2. So I'm going to substitute f of x with -2, and then I'm going to substitute each x with a 0. So I'm going to have a equals 0 plus 3 times 0 minus 2 squared times 0 minus 5. And I'm going to solve for a. So that gives me a, and then 3 times 4 times 5 minus 5 minus 5. Okay. So 60, right? So I have -2 equals a times 60 negative. So a is -2 divided by -60, and that will give me positive 1 over 30. Okay, so a is 1 over 30. Now I can plug this value of a into my formula and get my final formula. So f of x is 1 over 30, and then x plus 3, x minus 2, x minus 5. All right, so it's in factored form. If they've asked you for another form unfactored, then you would have to actually multiply all of these factors and do the quadratic, the square first, and then multiply all of the factors. We're not going to do it right now. This is good. This is done. But I want to do one more thing. I want to actually graph this, put in this formula and look at the graph and just see if it's going to match to what we have. So I have 1 over 30 multiplied by x plus 3 multiplied by x minus 2 squared multiplied by x minus 5. And there's our graph. We got it right. It's pretty good. All right. And now I want you to try these by yourself. See if you can come up with a formula and let me know if you have any trouble. I'm gonna zoom it in a little bit so you could see better. Again, if you don't see it very well, go ahead and look at the handout that's posted on Canvas. So it has zeros right here. It's -1, 2, and 4.